it's time to power it up and get to the guts of our Buddy. To boot up our Buddy, as of firmware release 5.07, simply press and hold down the control knob briefly until the Buddy LCD activates and lights up blue. At this time, the Buddy will prompt you to turn the control knob to finish the boot process and gain access to the Buddy. Upon successful power up, the Buddy will briefly display the current firmware version. As you can see, the additional steps added to successfully turn on the Buddy ensure the user won't accidentally turn on or off the Buddy when the control knob is accidentally pressed down. As might be assumed, the actions in reverse power down the Buddy. Just press and hold, continue to hold as the Buddy counts down, and upon prompting, twist the control knob to power down. With the Buddy powered up again, let's familiarize ourselves with the various menus and adjustable parameters. The default display showcases our timecode, frames per second, our timecode source preference, as well as RF channel currently being used, and also the current signal strength. Currently, timecode is running and our frames per second is set to 23.98, with timecode being fed by wireless transmission through RF continuous on RF channel 4. By scrolling via the control knob, we can view the additional information screens. Scrolling clockwise, we have display access to timecode and user bits. By pressing down on the control knob, we then have access to modify the user bits. Now, user bits dumbfounded me initially. In reality, user bits are whatever you want them to be. User bits are simply another form of non-pictured data stored on tape or digital medium. However, unlike timecode, user bits is stagnant, meaning it does not auto-increment. Only changes that occur are changes you set manually. User bits contain 8 spaces of data, each adjustable from 0 to 9 in A through F, known as the hexadecimal system. There's really no standard use for user bits, however, user bits are a great way to essentially ID your setup. For instance, if there was a different sound mixer every day of the week for one whole week of shooting, you might have 7 unique user bit sets stored within the video files or audio files, allowing posts to single out which mixer mixed what day during the 7-day shooting period. User bits can also be shown on smart slates and iOS devices using the Movie Slate app software or Buddy's own Timecode Buddy app. Additionally, user bits are a great way to notate the shoot date. User bits are there to be used in whatever fashion you deem worthy.
Now, user bits can be sent via the Buddy master via external BNC to whatever external source that is timecode feedable when the master is running in internal generator mode. You can also transmit user bits via Buddy data link to any other Buddy master listening on the same RF channel. Again, just make sure one Buddy master is set to internal generator and is transmitting timecode and user bits via Buddy data link. And the receiving Buddy master is set to external RF or external RF continuous to properly receive from the master operating in that internal generator mode.
Otherwise, when receiving timecode, the unit will likewise receive and pass on the received user bits designated by the external clock source.
Please note that transmission of user bits and timecode cannot be fed from a Buddy master to a Buddy TX. The Buddy TX can only transmit timecode and user bits fed from an external source to a Buddy master. It cannot receive, only transmits.
To set user bits, just press down on the control knob. The first field will blink, allowing that field's parameters to be adjusted. Just rotate the knob to make your adjustments. Clicking once again will usher you to the next field and so forth until you exit the user bit selection. Continuing to the next information screen, we have the Tvsync display. Currently, Tvsync is set to off. Pressing down the control knob does not give us access to change the sync settings. Once we get into the main system menu, we can do so. Tvsync refers to genlock or generator locking options where the video output of one source or specific signal from a signal generator is then used to synchronize multiple video sources together, such as would be the case on a television multicam shoot. For most applications, you won't usually need to take advantage of this feature as most projects run one-camera shoots. Even so, you can run multiple cameras without utilizing the Tvsync setting. However, drift over time can occur. Thus, Tvsync or Genlock is used frequently on television multicam shoots to maintain synchronous video signals over long shoot days. Continuing to scroll over, we have the power status information screen, which shows whether external power is being supplied or not, as well as the current battery level of the internally supplied batteries. By pressing the control knob, we can change the battery type to best utilize whichever type of AA battery we decide to use, such as alkaline, lithium, or nickel metal hydride. Next, we have the firmware version and serial number screen, which allows us to identify our Timecode Buddy as well as the current installed firmware version, serial number specific to each unit, and whether the device is running according to FCC usage in the States or CE frequency guidelines for European conformity. The next information screen showcases our currently selected Wi-Fi network mode in addition to displaying our Wi-Fi SSID or service set identifier name, which is the public name for a Wi-Fi network. Pressing the control knob, we gain access to user settings under the Wi-Fi menu. First, we have the option to turn on or off or restart our Wi-Fi. When Wi-Fi is disabled, the Timecode Buddy blinks green. When Wi-Fi is enabled, the Buddy blinks blue. You want to make sure Wi-Fi is enabled when wanting to wirelessly transmit accurate timecode and user bits to iOS devices running the Movie Slate or Timecode Buddy app. If no such iOS device is being used, then disable the Wi-Fi transmission to reduce battery usage. Next, under the Wi-Fi menu, we have network type options. The default network type is ad hoc. A wireless ad hoc network type is a method for wireless devices to directly communicate with one another, as it does not rely on a pre-existing infrastructure like routers in wired networks or access points in managed infrastructure wireless networks. In ad hoc mode, all wireless devices within range can discover and communicate in peer-to-peer fashion, void of central access points. Ad hoc mode is what you will want to designate when wanting to connect other iOS devices for streaming timecode. Selecting the infrastructure mode enables the Buddy to directly connect with a pre-existing network, such as a wireless router with access to the internet. I'll later show you how to use the infrastructure network type to access the internet to wirelessly update the Buddy's firmware. Next, we have the option to select our Buddy's ID number via 3 assignable digits. Our designation is a part of our Buddy's SSID name. If you're working on an event where multiple Buddies may be in use, the Buddy ID will help to differentiate to the users which Buddy should be paired with when streaming timecode. Lastly, we have the option to enter stealth mode, which, when enabled, is a battery saving mode. When power is being supplied externally, Wi-Fi is automatically switched on. When external power is no longer supplied or when turned off, Wi-Fi is automatically switched off to save internal battery consumption. Scrolling once more, and by pressing the control knob, we can exit the Wi-Fi menu and it'll bring us back to the default display. From the default display, by pressing the knob, we can enter the menu for timecode mode, internal generator, RF setting, the Wi-Fi menu, LCD backlight on/off settings, system settings, and again the option to exit back to the default display. Accessing the timecode mode gives us options to internally generate timecode from the Wi-Fi master's extremely accurate timecode generator, or whether to receive timecode externally via a hardwire connection or wirelessly via one of the 14 selectable RF channels. Let's talk about what the different options for generating or receiving timecode are. The initial mode selection is the internal generator mode. This mode activates the highly accurate internal generator within the Buddy Wi-Fi master. When in internal generator mode, we can then manually set our own TC, user bits, and frames per second settings. Always be sure to adjust the FPS setting to match the camera and audio frame rate designation. More on frame rate settings shortly. External RF mode constantly jam syncs the internal generator from the received timecode via the Buddy RF data link. If the Buddy loses signal of the received TC, then the TC output continues using the internal generator for 5 seconds, then will freeze at that point in time until connection is resumed and the timecode is again fed via RF transmission. Now, external RF continuous mode constantly jam syncs the internal generator from the received TC via Buddy data link, just like before. However, this time, if the Buddy loses the received timecode, the Wi-Fi master's TC output will continue on utilizing the internal generator. This is my preferred mode with the Wi-Fi master. The external BNC mode constantly jam syncs the internal generator from the received TC via the BNC IP socket or LEMO5 socket. If the Buddy loses the signal of the received timecode fed via the hardwired connection, then the TC output freezes immediately. Lastly, the external BNC continuous mode does just as before. However, when the Buddy loses the received TC signal, the TC output again continues on utilizing the Wi-Fi master's internal generator. If we scroll past the timecode mode menu, the internal generator menu displays. Entering the menu by clicking the knob, we have the option to enter and manually select the start timecode under the Set Timecode option, or by scrolling over we can manually set our user bits via the Set User Bits option. And lastly, we have the option to select our frames per second setting via the Set FPS option. Under the Set FPS option, we can choose the European frame rate standard of 25 FPS, 23.98 FPS for working with digital cinema cameras shooting at the film equivalent to actual 24 frame per second film.
Then we have true 24 frame per second for when working with actual film cameras, 29.976 or 29.976 drop frame video, as well as true 30 or 30 drop frame. Additionally, we can scroll through to the next option and return to the default display.
Now, I realize what I just said might be a little confusing in regards to frame rates, so let me explain the different options in brief. 23.976 rounded up to 23.98 on the Buddy screen is simply a television-friendly version of 24 true frames per second traditionally used in film. The difference between 23.976 and true 24 frame is very important to location sound recordists, as depending upon which timecode frame rate is designated corresponds to a very different required post-production path. Same goes with 29.976 and true 30 frame. 29.976 is again a television-friendly version of true 30 frames per second. When film is shot at true 24 frame or 30 frame, but then subsequently delivered for viewing via television, the frame rate must be slowed down to 23 or 29.98 frame for transfer to NTSC television standards. Now, in reference to either 29 and 29.98 drop frame and 30 and 30 drop frame, the drop frame option refers to essentially a leap forward in time, primarily with 29.98 frames, since the frame rate is 0.03 frames, a second slower than 30 frame. Without drop frame, the video's timecode will drift apart from actual clock time. When choosing a drop frame rate, it compensates for the fact that the NTSC format has a slower rate below a proper whole number, and since timecode can only be represented by whole numbers, a drop frame timecode rate periodically drops timecode numbers. This way the timecode number always matches the seconds and minutes of video that have played. NTSC can use either drop or non-drop rates. However, drop rates are preferred for editors, especially in regards to expensive broadcast markets where timecode that accurately reflects the exact duration of a program on tape is much needed. If we continue to scroll over to our RF settings menu, upon entering the menu via the knob, we have the option to designate our RF channels from numbers 1 through 14. All buddies on the same RF channel are able to effectively communicate with each other. Under the RFTX or transmitter on-off selection, when in internal or BNC modes, the Timecode Buddy Wi-Fi master can transmit its SMPTE TC data via Buddy data link to any other Timecode Buddy Wi-Fi master which is listening on the same RF channel. Scrolling past our RF settings option, we again arrive at the Wi-Fi menu. Again, here we have the ability to stream timecode over a Wi-Fi network for connecting iOS devices running the Movie Slate and Timecode Buddy app. As an additional note, when Wi-Fi is turned on, the antenna halo flashes blue every second when timecode is running. When Wi-Fi is disabled, the antenna halo flashes green every second when timecode is running. Whenever timecode is subsequently not being fed via an external timecode generator source, then the halo will maintain a steady blue glow with Wi-Fi enabled, and a steady green glow when Wi-Fi is disabled. Now, we have an option to turn the LCD screen backlight on or off. The backlight is perfect when working in low light situations. However, when using in broad daylight, you might want to turn the backlight off to save battery when utilizing internal powering of the unit. Under System Settings, we have access to set our Tvsync. We can keep this function turned off, or via the Wi-Fi Master's BNC Sync out port, we can gen lock to PAL, European Television Standard Video, NTSC, US Television Standard, as well as 720p, 720p2, 1080i, 1080p, and 1080p2.
720p stands for 1280 by 720 pixels shot in progressive field order. 1080i and 1080p record video at 1920 by 1080 resolution in either interlace or progressive field order. Both 720p2 and 1080p2 correspond to double frame rates.
We also have the option to designate the Tvsync level from standard to high. Under Set Country Area, we can only view the applicable countries where use of the Buddy running in the 915 MHz band is allowed. Next, we have the option to restore the Wi-Fi Master's default settings. Under Display, we have the option to adjust the LCD backlight brightness from 0 to 100%. Additionally, we also have the option to flip the display orientation upside down for left and right-handed use. Lastly, we have the option to set a passcode. Choose a passcode to allow access to setting changes from the Timecode Buddy app or Movie Slate app directly. The Wi-Fi Master passcode by default is 1111, but can be changed to any 4 digits. With the Timecode app software loaded up on an iOS device, simply enter the passcode and access to Buddy changes are allowed. I'll cover the Slate apps coming up. In the following tutorials, I'll cover the Timecode Buddy TX, Buddy Web View, how to update the firmware in the Buddies, as well as features and functionality of the Timecode Buddy app and Movie Slate app software, and how to implement the Buddies in paired iOS devices in a timecode workflow scenario. Thank you so much for watching. As always, keep exploring the possibility of sound. I'm Jonah Guelzo with Audiotuts Plus. I'll see you next time.